So welcome everyone, good morning. Welcome to our monthly webinar series. This one is called Scaling Up Your Knowledge of ArcGIS Imagery. Just want to apologise, our cameras aren't turning on today. I don't know if it's something to do with the weather or what's happening, but yeah, we're very, very sorry. You won't be able to see our faces. We do have a slide with our faces on, and I can assure you we are all here. So yes, so thanks for joining. So great to see so many of you on. We have some great presenters today and the opportunity to QA them. As you can see, the details of the Slido Q&A are on the screen, on the slide for you. Just really urge you to register for that now while we're waiting to get into the demos. I'm sure you'll be excited by what you see and you'll want to find out more. So thank you for joining us. So before we see the demos and the presenters, just want to remind you that this webinar is being recorded and a link will be shared in the follow-up email. The follow-up email will also include some links to some useful resources. There will be a Q&A at the end and you could submit questions at any time via your Slido. And I really want to stress the importance of upvote for any questions that you're really interested in, because we've got loads of participants on today. So great to see such an overriding interest in imagery solutions in ArcGIS. And we will have lots and lots of questions, I'm sure. So if you upvote the ones that are you're most interested in, these will get to the top of our priority list and we'll make sure that those are answered, but we can't guarantee we'll be able to answer every question. Polls will also be available in Slido for you to be able to provide some feedback. So my colleague Claudia is managing that. Thank you, Claudia. And that will happen throughout the demonstrations. You can access Slido by the details on the screen again. So we've got the QR code and the URL and the event code on there. So please go ahead and do that. With that, it's time for us to introduce ourselves. So I'm your host, Nikki Goodwin, Principal Consultant at Esri UK. And not sure why I did today, but there we go, because you can't see me. I've got a really strong background in remote sensing and imagery, hence my interest in hosting this webinar. It will be fantastic. We've got some great presenters and so much for you to get your teeth into and hopefully take back with you in your workflows. So with that, I'm going to hand over to my colleague James to introduce himself.
Hi everyone, I'm James, a graduate GIS consultant here at Esri UK, and I currently work in the pre-sales department doing demos to customers and doing things like this and showing off our technology. So yeah, that's a bit about me. Handing over to Miles.
Hello everyone, I'm an Academy GIS consultant at Esri UK as well, and again, like Nikki, I've got a strong background in remote sensing and a particular interest in photogrammetry and 3D constructions, and I'll pass on to Mark.
So I'm the lead for some of the capabilities that you're just about to see, but really this is about 3D GIS, digital twin, and really, in a nutshell, high resolution visual intelligence. That's what this is really about. And I guess you're here because you think it's important to know more about it, and I think you're right. We'll show you, or James and Miles will show you how to do this, but what I'd ask you is just to think a bit about what you're going to do with it. Nikki, back to you.
Thanks, Mark. So as you can see, there's quite a few today, quite a lot of expertise in the room. And I think it's really important to remember what Mark says. It's about what you can do, and that's really important for us. And it's so good to see some of my government customers. So I work a lot in the government space, and also to see new customers. It's really nice to meet you and have you on this call. So with that, let's look at some imagery sources. So today we have more sources for imagery and other remote sense data than ever before. It has been termed by the industry as an explosion of sensors. And I really love that term because actually that means we need also an explosion of solutions. Makes sense. And that's what we're here for. And that's what we're here to demonstrate with our ArcGIS imagery solutions. So fasten your seatbelts. I'd really like to cover some of those ArcGIS imagery solutions just in an overview before we dive in a little deeper. There are so many ways to capture imagery. As you can see, we've got satellite, aerial, drone and ground-based, lots of different platforms. We'll demonstrate what tools are in our system to help process, visualize, analyze, extract and share outputs from these sensors. And I'd really like to introduce some of these solutions that will be explored in the webinar. So today, just to sort of outline the scope a bit, we will be focusing primarily on Pro and the Reality Suite, but this slide really shows the plethora of tooling and options available. It's really important, I think, to note, as Mark was saying, that the sensor inputs and the scale of your project or the service you're trying to create will dictate what ArcGIS software and solution will be most applicable for you. So in the center of the slide, we've got the Reality Suite with a really powerful engine. And I think Miles will be demonstrating Reality. And James will also be looking at site scan and exploring its capabilities. So for drone imagery, we've got drone to map and site scan, which you'll see. It's really important to understand in this suite, it is that same powerful engine all throughout. For most aerial sensor inputs, the workflows in Reality for ArcGIS Pro and Reality Studio will be applied, and Miles will be demonstrating that at city level, but these can also be applied at national level. I can see that we've got some of our Ordnance Survey customers on the call, and it was really great to hear them mention us and Reality in their 3D webinar earlier this week on Tuesday, so some of you might have been there for that. It was just great to highlight the partnership and just to hear that they're truly scaling up. There's no one bigger really in GB and trialing some of the tools at a national scale. We also have on the right there ArcGIS Excalibur, a powerful interface for viewing and labeling oblique and other imagery types and change intelligence inputs. It's really easily shareable as project spaces and easy to export as reports. And then of course we've got ArcGIS Pro with Image Analyst and 3D Analyst. James will demonstrate how to work with LiDAR data in Pro, and he'll also show how powerful that tool is for classifying, analysing your imagery. And I think you'll just be blown away by how easy that is to use and apply in your own workflows. And then bottom right, I don't know why it's bottom right, we've got our large scale solutions to aid large volumes of imagery management, which is a real struggle for a lot of you, our customers. Processing, analysis and publication of those ArcGIS image, where we've got server, ArcGIS Online and a SaaS Kubernetes option in image dedicated for tiled and dynamic imagery. I just want to highlight actually, for reference and guidance, we do have the ArcGIS well-architected framework, which outlines the patterns of imagery solution and also gives you a bit of guidance and recommendations on best practice, how and when to apply them. So you can think about the scale of your endeavour, and that should give you some guidance on what components and what solutions are best for you to use. We can, it's searchable via the internet, but we can also put the link to that in the follow-up email. So I haven't mentioned satellite yet, which is interesting, as we will be focusing on aerial and ground-based sources in this webinar and not showing any Earth observation today, although it is a big topic for us and we have covered it quite a lot previously. So our annual conference collateral, as shown on the slide, and we've also got a webinar recording from May, which will give you a lot more information on satellite imagery and the relevant ArcGIS workflows, solutions and tools available for you. So really urge you to go and interrogate that when you get the opportunity to expand and complement what you're going to see today. So let's look at the data types that we'll be looking at today. So I just wanted to introduce some of these. We'll be highlighting in the content some of these that you're about to see. It will provide a feast for your eyes. What struck me about this slide is actually as imagery, photogrammetry, remote sensing, geospatial, people, we actually love to see this. We love to see imagery on a slide, especially 3D, as Mark was saying. So it will be a feast for your eyes, and this sort of highlights where we're going with that. So James will start us off by showing LiDAR classification workflows in Pro and show the power of that. Then he'll move on to some drone mapping in SiteScan, really highlighting the capabilities of SiteScan. I think it'll be eye-opening to show how easy some of the tooling is to use in Pro to classify. Speaking as someone who tried to do it 6 or 7 years ago, it's really come along. Miles will then give us a quick reminder on photogrammetry, a bit of a 101, which I really benefited from, not having seen those equations for a while. And he'll move on to talking about using multi-sensor imagery in a demonstration of ArcGIS reality capabilities, and touching on 3D as well and the digital twin ethos and focus that Mark mentioned. He's using aerial imagery inputs, and will show scaling up options that push our tech to its limits with a Cambridge case study demo. The demo, spoiler alert, is really good if you like trains, 3D buildings, lampposts, you're in the right place. And then Miles will also showcase the possibilities of using ground-based laser scanning and exploring our oriented imagery capability. So I think that's a spoiler there, because that's where the lampposts feature. So apologies, Miles. But James is going to start us off. So I'm just going to hand over to you, James, to kick off the demos.
Thank you, Nikki, and hopefully everyone can see my working with LiDAR in ArcGIS Pro slide coming through. So firstly today, I'll be speaking about how you can work with LiDAR in ArcGIS Pro, looking at some hints, some tips, and some things I've learned along the way. And if you do have any questions, please do put them in the Slido, and the QR code is just here as well. So what does LiDAR mean? LiDAR stands for light detection and ranging. So how does that work? Well, sensors emit pulsed light waves into the surrounding environment. And then these pulsed light waves bounce off objects and return to the sensor. The sensors use the time it took for each pulse to return to calculate the distance it's traveled. Then, using complex algorithms and machine learning tools, we're able to differentiate between the ground and different vegetation types and even buildings. So what am I going to show you today? Well, firstly, I'll touch upon different LiDAR data types and things you might see and how you can add it into Pro. I'll then look at how you can symbolize that data and using different classifications. I'll also show you how you can edit. I'll show you how you can extract individual classification types, which will then lead on to your ability to create digital elevation models or digital terrain models by just looking at the ground. And then lastly, I'll show you some elevation profiles. So LiDAR data types. If I just go back. There you go. So the industry standard that you'll come across a lot will be a .las layer. So this is the industry standard binary format, and you should see this a lot. You may come across a .laz layer. Now, a .laz layer is essentially a compressed version of an LAS, and this can be extracted using the Convert LAS tool in ArcGIS Pro. And just lastly, you may see, and I use it today, a .lasd layer. Now, when you add LAS data to ArcGIS Pro, an LASD file is created and stored on your disk, and it essentially points to the underlying LAS data. So without further ado, let's jump into Pro. So first of all, I've already added in my LAS data, and it's as simple as kind of dragging and dropping in. And once it's loaded in, we can see all of these points. And the cool thing with LiDAR data is if we select the feature, we can actually see 3 new bars at the top have come through. So we've got our LAS dataset layer, we've got our data, and we've also got different classification. Now, automatically, when you load this data in, we can see we have eye dome lighting turned on. Now, this is essentially a shading technique, which allows to really bring out the 3D kind of environment. So if I was to turn this off, we can see it's got a lot flatter and it's a lot harder to kind of understand the 3D environment. So I'm going to turn that back on. But we can also set the strength and the radius of these points depending on what you need. Also, the point thinning and the display limit is a really interesting thing to watch out for. You can actually increase this. And this essentially means you can increase the number of points being displayed, or you could reduce the number of points. And this can be really beneficial in terms of performance. If you're using a computer that's notoriously slow, if you could reduce this, it will make your life a bit easier. So once you've loaded this data in, it automatically loads in as elevation data. So we can see here in blue, I've got my low-lying areas, and then in red, I've got my areas of high elevation. But we can also symbolize this data based on other features. So here I have just swapped tabs to look at a building within my LiDAR data, and we're still looking at the elevation symbology. If I was to click my layer, go to LAS dataset layer and symbology, I can select I can then, on the right-hand side, we can see I've currently selected elevation. If I drop down and chose classification, it would update and will show the different classification features. So for example, I've already
James,
got
so
one here.
sorry to interrupt, but I think we're seeing the wrong thing at the moment.
Oh, apologies. Get my share right. Window.
Sorry, sharing on here can be tricky sometimes.
Live
Is
demos
that
can be
coming through
really
now? Hopefully it's
tricky.
going through now.
Fab, yeah.
Yeah.
Cool. Shall I continue where I left off, or shall I go back to the start? I can continue where I am. So currently, we have our data classified here, and we can see I have unassigned and never classified data in grey, and then I have in red we have our buildings, and then I have my different vegetation types in green, in different shades of green. Now, using the LiDAR tools, I'm able to actually filter out this data set. So if I click on my feature, make sure I go to LAS dataset layer, and then select LAS points, I can unassign unassigned and never classified. And if I was to click apply, we will then see the resulting output here. So you can see it's a lot clearer and a lot more crisp to understand what you're actually looking at. But we can also go one step further. We can actually remove all the data points and just look at the ground. Or for example, you could remove all the points and just look at buildings. Now, here's an example I've made where we can see just the ground layer. And all I've done is I've gone to LAS points and selected just the ground. And now this could be used when creating digital terrain models, and I'll show an example of that later on. So moving on, sometimes you'll be working with your LiDAR data, and you might notice some issues, some errors, some points at which you're not too happy with. Maybe the LiDAR data is a bit wrong. And we can actually start editing and analyzing that data to understand if it's correct, and then if it is incorrect, we can change it. So all I have to do is I go to my layer, make sure it's selected. I can choose my swipe tool. Now I can actually drag down and I can see the underlying layers below. Now currently I have a world imagery base layer, so I can actually see the buildings. I can see how they're drawn in. I can see if these classifications are correct or not. And if I continue down, we can actually see that my building here is actually completely incorrect and it's wrong. And I want to edit this. How do I do that? Well, I go to my classification tab at the bottom, ensuring to click my LiDAR data. Click classification. I can then choose my classification code. I'll select it to be ground. And then if I click select, I can then select all the features that I want and click apply changes. And now we've edited the data to ensure that it's correct on the fly, nice and easily. Now, once we've got this LiDAR data, we might want to create raster outputs like DEMs. Now, I'm currently looking at the data in a 2D environment. So in the past, we've been looking at 3D scenes, but we can look at it just as well in a 2D environment. And you can see it's quite thin. But if I start to zoom in, it will start loading in a little bit better. Now, to create a digital terrain model, we have to go to our data, we'll click export, and then we'll go to export raster. Then on the right hand side, we get the geoprocessing pane for creating a raster dataset. We'll select our inputs, we'll select our outputs, and then we'll also select things like the interpolation type. So I quite like to use triangulation, natural neighbor, and I would really recommend you have a play around, and depending on the different kind of LiDAR data you have, will it to kind of impact your sampling values and your Z factors. And I would really recommend having a play around and doing a bunch of different tests to see how you could get the best result for your data. Now, I would click run, but it can sometimes, again, take a while. So I've got a Blue Peter pre-made one here. So if I just zoom out, we can see my digital terrain model. So this is just using data from the ground. And we can see that I've actually created a DTM for the whole LiDAR data set. But sometimes if you have a really, really large data set, you might only want a small snippet, and this you might want a small snippet. So I have a shapefile here that shows a little corner that I want to show. And we can clip this by using our environments under our LAS dataset to raster. And I can select processing extent. And I can set my processing extent to be that, that layer. Once I select that, it sets the top, left, right, and bottom coordinates. I can click run. And then the resulting output should look like this. So if I turned everything else off, we've got a much smaller raster dataset. So lastly, I just want to show you a fun tool that you can use in ArcGIS Pro. So I'm back to where we started looking at elevation data. And if I go to my analysis tab at the top, I can actually select exploratory 3D analysis, elevation profile, and then we can start to create elevation profiles. Now you can use interactive placement, which is essentially clicking a point and then double clicking. But you can also use along a line. So for example, if you had a line file that you wanted to measure across, you could use that as well. Now it basically draws a line between the 2 points and creates a graph at the bottom showing the elevation profile. And one cool thing is that as you kind of drag across the graph, we can actually see on the map where these where this location is. And I think it's a really fun tool, and you can also export this to kind of have and kind of be able to really quickly look at your data. So that has been a whistle-stop tour of LiDAR in ArcGIS Pro. I'm now going to speak to you about the capabilities of site scan for ArcGIS. So what is site scan? Well, site scan is a cloud-based drone mapping software that provides an end-to-end solution for imagery collection, processing, and analysis. Now, today I'm going to focus mainly on processing and analyzing your data. We can also plan and capture, and you can also actually start collaborating and put your data into ArcGIS Online. So here are some kind of examples that you can look at when looking at site scan. For example, we can create orthomosaics, we can create 3D point clouds and meshes, but we can also create things like digital elevation models, just like I've showed earlier. So without further ado, let's jump in to site scan. So hopefully everyone can see that. Yes, should do. Cool. So for context, we have flown a drone around a water treatment plant, collecting 71 images around the site. And each one of these images are symbolized based on the dots here. Now I can actually, once I've uploaded this, I can investigate the individual images. So I've just clicked on one point here, and we can see the photo that the drone has taken. If I was to move across to another one, it will then show the photo taken there. And the goal of site scan is to merge all of these data together to create a true orthomosaic. So how do you do that? So once the data has been uploaded, we come to the bottom here, click process mission. I can then set the output quality. I can select if I want to generate a mesh, and then click process mission. Now, depending on The size of the images, the number of the images, the processing time can vary, so do keep that in mind. But once it has processed, this will be your end output. A really, really nice, crisp, true orthomosaic. So it's essentially that combination of all of the images into one. And this has been using that reality engine to kind of combine it all together. But it doesn't just stop there. We can also look at elevation data from a click of a button. For example, I can start to look at contours. I can set the major and minor interval. I can look at elevation models. I can look at the digital terrain. I can also, from a click of a button, also look at hillshade. So I spoke about how we can kind of collaborate, and we can also download this data. If I click export at the bottom, we can actually export the true orthomosaic, we can export the DSMs, DTMs, we can export contours, and we can also export point clouds and mesh. And I'll talk a little bit about those in a minute. But within this site scan view, we also have the ability to start making measurements. So I've made a couple of measurements here, but we can see on the right-hand side, we've got kind of line tools, a volume tool, and a marker tool. Now, I have made a couple of measurements around this water plant. And we can see here that around this, we have a net volume, and we can also look at the net area. But one really cool trick that you can do is if you actually click View and Edit Volume in 3D, we can actually look at the environment in 3D and start to understand what it looks like. So for example, if you flew a drone around a building, we could turn this into, we could select a shapefile around the building, and we could generate this 3D output to investigate it more. And I think this is a really cool tool. But like I said, we also have other tools like the ability to measure distances in a line. For example, this here is 71 feet. And then we also have the ability to actually investigate the underlying images that have created this image. So I've kind of added a point here, and we can see all the nearby images that would have been used to generate the final output. Now, I spoke a little bit earlier about how we have the ability to look at 3D data and point clouds. And here is the output that is created from SiteScan once you've processed your mission. It's a really cool point cloud data set that can take a little while to load in, but we can kind of fine tune that using our point budget and our point size. And in this 3D environment, we can also start taking more measurements. But I'm going to jump into our mesh. So we have a 3D mesh here. And this is essentially the best of both worlds. It is a combination of the point cloud and the true orthomosaic to create this almost as realistic as possible 3D environment that you can explore and interact with. And I really like playing around with this and kind of looking around and finding new features. Now, you will notice there's some kind of areas where it doesn't work as well. And this can usually be because of trees, for example, aren't static and they may be moving as the images are taken. But as drone imagery gets better and as these engines get better, I'm very confident that this will just get better. Now, earlier I showed you elevation profiles in Pro. Now we can do the exactly same thing in SiteScan. So if I just swipe on over, I've actually drawn a line across an embankment here. And like in Pro, I'm able to kind of investigate the line and kind of see how the elevation changes. I can see the distance, I can see the height. But if I was to zoom in, this is the one key thing I like about SiteScan, is I can zoom in and see these kind of minute changes, these minute undulations in the surface. And I can actually watch those changes as I go. So that has been a whistle-stop tour of ArcGIS Pro, looking at LiDAR, and then also looking at SiteScan using drone imagery. So I'm now going to hand over to Miles, who will speak a bit more about reality engines.
Thank you, James. That was really useful, showing you kind of how to do LiDAR analysis on the fly. But my section of the presentation will focus on what's possible and really stretch the Esri technology. So ArcGIS Reality Studio really provides a gateway to crafting ultra-high resolution digital twins at an unlimited scale. This is a sneak peek about the art of the possible, Some of you may recognise this as Cambridge. This visualisation opened my eyes as to why reality has often been described as the engine to rule them all. And let's delve into how this is possible. So, but before I go into that, let's talk about photogrammetry 101. Now, many of you will see this equation on the right-hand side and panic. Don't worry, you won't need to solve this at all. But back in the days when I had to do my photogrammetry exams, I had to solve it with a piece of paper and a pencil. But thankfully, this is the maths used in photogrammetry to basically work out accurate measurements from images and also reconstruct 3D scenes. And this is baked into ArcGIS Reality Studio. So as long as your images have an X, Y, Z, a kappa, phi, and omega attribute attached to it, we can perform photogrammetry. So why ArcGIS Reality Studio? Well, what imagery is being used and what is the scale of the project and what metadata do you have? So that kind of defines which suite of image processing tools you should use. So we've got drone to map as mentioned, that's for drone along with site scan, and Reality for ArcGIS Pro is more satellite and also aerial imagery. But Reality Studio again is the same sort of stuff, but it's for aerial imagery and it's for large scale stuff. And then also metadata. So if your images have georeferences attached to them, drone to map and site scan work really nicely. But if we've got some slightly more complex metadata in a separate file, this is where Reality Studio comes into play. So what are Reality Studio capabilities? So it takes an input, so that would be imagery, control points, this is optional, and also camera geometries. Once you've got that, we can perform an alignment. So we'll process it. You can also edit your alignment and you can also refine and report. Once we've aligned, we can perform 2D and 3D reconstructions. So whether that's an orthophoto, a DSM, a point cloud, or a mesh. And also we've got distributed processing. So this is what allows for national scale mapping. So you can have multiple machines all working together to produce the one mesh, point cloud, ortho, mosaic, or DSM. Now, I'm going to jump into the Cambridge Reality Studio case study, and in the background, again, this is Cambridge, but it's been processed using Unreal Engine to provide this gamified experience. So the camera that was used to capture this data was the City Mapper 2. It's provided by Leica. It's got 5 different cameras, so forward, back, left, right, and the deer looking straight down, as well as a LiDAR and a near-infrared sensor. So this is one of the images captured of Cambridge, and you can kind of see the quality of the data that we're using, and this was all provided by Blue Sky. And again, this is zoomed in, gives you an idea of how the mesh generates such good quality later on. So we'll jump into the metadata. So obviously we've got the image, but how do we use all the metadata to calculate where the images are located? So with the imagery comes a report. So we've got the serial numbers for the cameras, and we've also got the specifications for the output images, so nominal focal length, pixel size, rows, columns, etc., etc. And this is all used alongside the image names, the X, Y, Z, omega, phi, and kappa to reconstruct everything going forward in Reality Studio. So what is the Reality Studio workflow? So at a very high level, we start with a capture session, which is the capture session name. We import the metadata files. We locate the orientation file path, and we choose our spatial reference. We can also include area of interest or a water body as well, as also control points, but this is optional. Once we've done that, we define our camera parameters, so we can go through and define the sensor characteristics and choose the distortion model if that's what you wish. And then we can run the alignment. So we can measure the control points as well to verify the alignment quality. We can export the alignment report, and we can produce frames and camera tables, which can be used for other processes such as oriented imagery. And in the image above, you can see how the Leica City Mapper 2 looks with the background overlapping images in the background. So once we've done the alignment, we can run the reconstructions. This is looking at 2D and 3D. So we can either run true orthomosaics, DSM, mesh, point cloud, and you can choose a format for the reconstruction, but quite a popular one is an SLPK file. And once we've created that, we can share the reconstructions in ArcGIS Online or Enterprise or a physical file on your laptop. So a nice feature with Reality Studio's distributed processing. So if you're trying to produce meshes of cities, such as the one in the background, one laptop, one computer is really going to struggle to do this. So we can have multiple different computers all working together, and this is contributing to a workspace. So you can connect a workspace to an existing project and assign tasks to each different computer. But let's say you want to monitor a workspace, you can also do that from your laptop, and you can decide which processes get assigned to which computer. So on the right, this is the Cambridge case study I mentioned previously. You can see how it's tiled it up and it's distributed all the processing out to 3 different computers to get the mesh generated. So with further ado, I will jump onto the Cambridge demo. So this is the mesh created in ArcGIS Pro, and it's a local file, and you can see how well it renders, and also how well the detail comes through. So just give it a second to load, and it comes through really nicely. And the idea behind this was for asset inspection. So we've got the Cambridge railway station in the background.
Miles, it's not coming through actually. I've just got
Apologies.
slightly. Yeah.
Let me try again. There we go. Apologies.
Yeah, Miles, it's there.
So it's come through now. You can kind of see this is a local mesh of Cambridge, and you can see how well it's rendered.
It's gone again for me, Miles.
Yeah, sorry, it seems to have gone
Sorry,
again.
Miles. We're all rooting for you. Try again.
Okay, one more time.
Yeah.
It's back again now, Miles. That's it.
Okay, right. Fingers crossed. So you can see this is Cambridge, the Cambridge mesh, and how nicely it's rendered. And this piece was designed for asset inspection along the Cambridge railway station. And we can see, it's rendered really well for big stationary objects. However, in other places, it may not have rendered as nicely. So if we zoom in and start looking at lampposts or people or bikes, it hasn't picked it up. And that's because of the image quality. But a really nice tool we can bake into this is oriented imagery. So if I click on the oriented imagery layer and explore the images, you can click on any point you want. So if I click on these people here, give it a moment to load. Now these images are massive, so they do take a second to load. There we go. So you can see it's lined up really nicely to the cross. And if I zoom right in, you can see how clearly it's done. So actually, given the image quality, this mesh has done a really good job. Now, we can also include the current footprint. So here you can see exactly the viewpoint from the aircraft. So if I zoom in and out, you can see how that changes on the fly. But let's say, hang on, I want to see the other side of the umbrella. All I need to do is look at my compass and click on one of the images from the other point of view. So we'll give that a second, and that should load and show us the other side of the umbrella. Nope, that has not. Let's try again. Give that a second. There we go, it's worked this time. So you can see how the oriented imagery, you can use your compass to assess and work out the view you want to see. Now, really handily, we've also got image enhancement, so we can play with the brightness, contrast, and sharpness. Now, what if we don't want to work in ArcGIS Pro? What if we want to work in the web? Well, we can do that as well. So let me share my other screen now. So that's come through. So this is the same mesh, and it's hosted on an Amazon S3 box. And you can see you've actually got improved performance with how the mesh renders. And you can do exactly the same stuff. So we can pull in an oriented imagery layer. So again, I've clicked on a spot. We can use the same compass, zoom in and out, and look how quickly it renders. We can also start measuring things. So if we want to measure the height of a building, we can do that. Or if we want to do an area measurement, we can also do that. And as I mentioned before, we have the same capabilities with the image enhancements, and we also have a gallery. So whatever image intersects with the cross, it pops up and you can select and see it. So if I click on this one, for example, there we go. So you can kind of see that there's also a web application for this as well. So let me jump back to my slides now. So I'm going to jump on to a ground-based demo, and this is carried out in Experience Builder for developers. So I must mention the partners who have enabled me to build this demo. So Blue Sky and Jorvik Design Group have provided the 360 ground imagery, and Nodology have provided the interface within Experience Builder Developer to run the simulation, and Solantor have provided the image blurring, so facial blurring as well as number plates. So I will jump on and share the demo. Apologies, there's so many different screens to share. Here we go. So as you can see, we've got an experience builder, and this can be published to the web. And in the top left, we have a 360 imagery. So you can see how Solantor have done a brilliant job blurring out faces, number plates, making sure all imagery is GDPR compliant. Now in the bottom left, we have a 2D map. This shows the route of where all the photos are, alongside a nice viewing port to show the look direction. Now, I can use the arrows to move along. So if I want to jump along one image at a time, I can do that. Or if I want to put it to 5 or 6 images, I can do that. I can also make it play like a video. So if I want to run it for every image, it will just keep cycling through the images to give you almost like a real-time video feel. I can also pan to the image and auto pan. Now I've linked in these maps on the right. We've got a scene viewer. So if I look around, I've got a nice lamppost, as Nikki mentioned earlier. The one that I like to do is, so again, this is asset inspection focus. What if I want to look at this in the point cloud? Well, I can zoom in here and you can see the scene viewer on the right is linked to it. So if I zoom in here and I'll rotate this, we can now see the lamppost. And this is a TLS point cloud in full resolution, so you can see how well, again, it renders in the web. So if I want to start measuring, I can do that again as well. So there we are, I've got a nice lamppost of about 7 meters tall. And again, we can look at area measurements as well, but they're a little bit more tricky to play with. But this kind of gives you an idea of what is possible within the web viewers. So I will jump back to my slides. And I'll hand back to Nikki. Thank you.
Thank you, Miles. Thank you, James. Really brave to do those live demos. I think we can all agree. And we're back. So much to see, such fantastic content, but not much time for the Q&A. So we're going to really jump ahead in this, but just a quick shout out and reminder that our last webinar of this year will happen next year, next month, so December, and the details are on your screen, hosted by Claudia. And without further ado, we'll jump into the Q&A. And just by the way, the details of this webinar will also be in the follow-up email that you'll receive.
Right, so Nikki, I'll go first. It's Mark here.
James, hand over to you, Mark.
Yeah, James, if you can pick up in a moment the question that's right at the top on LiDAR on pre-processing, but just a few questions I've seen in there. Site scan and drone to map was a question, what's the difference? Very simply, site scan is hosted in the cloud, it's online, and all the processing is done there. Drone to map, it's an application that runs on your workstation or laptop, and it runs there. The engine is exactly the same, so imagery and everything else being equal, the result should be the same. One question I did see that probably needs just a sort of main points on how accurate it is. What's the accuracy about? There's lots of factors there, but just to give you a feel for it, depends how high the drone's flying. It flies low, are we going to get better resolution of the data, higher, less resolution? There are some other factors there as well. But also in terms of sort of the accuracy of the data itself, there's three bits to it really. There's the relative accuracy. So on the mesh, measuring distances on the same mesh, it's going to be within a couple of pixels. So if you're down at 6mm resolution, you get the idea it's going to be very accurate. Absolute accuracy is where the mesh is matched to something else, an ordnance survey map or some other data. That's very different, and there are sort of a whole load of techniques for making the data more accurate. We just don't have time to do it. But the third one you want to think about is a temporal accuracy. So yes, everybody say, I want this data through in an hour or so, but I may be interested in what happened on the 15th of November. So there's a temporal aspect to that as well. So James, you ready on that LiDAR question that was right at the top of the list?
Yes, thank you, Mark. Sorry, really good question, Tom. So my LiDAR data was pre-classified. And if you do buy LiDAR data, you can get it pre-classified. But we do have tools in ArcGIS Pro that allows you to extract the ground and buildings. And just recently in the Pro 3.4 update, there's actually been an improvement to building extraction with LiDAR. So it is possible, but there is a couple more steps involved in it if you do have to manually process it yourself.
And I'm just
Do we want to?
You're out of time.
Sorry,
now,
Mark.
Yeah, we're out of time.
Can we just get a question for Miles? Really interesting one around the Cambridge demo. How long did it take to get from LiDAR to a workable model?
Yeah, great question. So rather than LiDAR, it was actually the images. So for the photogrammetric processing time, this all depends on what computation power you have. So if I had 3 different machines all running about 128 gigabytes of RAM, all with GPU cards, so it was roughly about 8 hours per tile for a full tile. So I think it took about 48 hours in total. But this, again, could be sped up if you add more computational resources.
Thanks, Miles. And we are at time. Sorry, we are at time, but we're happy to stay on for a few minutes and answer a few more questions if you are. So I know people will be dropping off, but we can do that, can't we, guys? Sorry, Mark.
Nick, just to add a bit more to Miles. Those numbers sounded huge, but what I would say is using the engine for something on a much quicker, smaller job, and we have done this for the military. Drone goes up one orbit, 20 or 30 images, lands, get the card off. That will process in less than 10 minutes. So depends on the size of the imagery and the processing power you've got and the area you're covering. But anything from a couple of minutes up to, as Miles mentioned, 8 hours or more. It's about the size and the resolution of the data. Sorry, back to you, Nikki.
Yeah, so the distributed processing is really important. There's a question for James also around what special extensions you need to perform these LiDAR functions in the classification, or whether it's built into Pro. I think it'd be good to just address that possibly.
Yeah, so everything I showed today should be using the 3D Analyst tool, which is available through a professional plus user type, I believe. So everything I showed there uses that tool, but then there are some capabilities with the image analyst extension as well, and it can just depending on what you're looking to achieve.
Okay, thank you. One more for Miles, if that's okay. Can I mix sensors with reality, aerial survey and oriented ground imagery for facades? Now, that's sort of a digital twin, isn't it, really, Miles? So
yeah, so if you were to use let's say a drone, you just want to process your drone imagery and then again process your other imagery separately. But if you were to produce a point cloud, there's no reason why you couldn't merge the point clouds or potentially crop a 3D mesh from one sensor and smash together the other sensor to make it all work. So yeah, the answer is yes, but it is a bit tricky.
It is, isn't it? There's quite a few questions around that sort of similar vein as well. And just lots of questions about where we can get LiDAR data, because it just sounds like everyone's really excited to try it. And then, Mark, there were some questions around how site scan and reality can be accessed by customers.
So it was a bit like the drone to map question. You've got to remember that the engine is common throughout 4 of the products. So site scan, which is online, as I mentioned, drone to map, which runs on your workstation, the reality extension that's in Pro, and the studio that Mars was showing. So it's available in all those products. What I would say is you're sort of almost moving up the sort of the food chain in complexity. You saw James press the button, high, medium, low, ultra resolution, do on a mesh, off it goes. And as you move up through the rest of the products, you get more control over the engine, and it's designed to be like that. So it's sort of ease of use is it's easy at site scan, and you saw Miles going through the things you've got to do at the other end. And also in terms of the areas it's likely to process. So site scan will do 3,000 frames, 3,000 images. Drone to map will do 30,000, and the numbers get really big as you move up further. Certainly some of the municipality data sets I've seen have got up to 70,000 frames, 70,000 images processed into one 3D scene. Let's park it there.
Okay, thanks, Mark. I've got one more really interesting question when we're talking about thin structures, I suppose, but this is related to point clouds, which can be either LiDAR, can't they, or photogrammetric, either one. So it says, are there any functions for identifying power lines in point clouds? Which is a really interesting question. I don't know who can answer that. Is it James? Is it Mark? Is it Miles?
We do have
Anyone
some
got one?
deep learning tools that can identify this, so that might be worth trying those out.
Yeah, I'll add a bit more to it. So it's not so much in the LiDAR, but in the photogrammetry space, the reality space. Esri are doing a lot of work on picking up thin structures. And it's basically if the resolution of the imagery is bigger than the thin structure, then it's not going to resolve. You saw that on the bit that Mars was showing. But there are improvements literally going into reality this month to make that a lot better. I would say in terms of looking at these 3D scenes, these digital twins, resolution of those thin structures is where the biggest improvements have been made. And certainly if you look at site scan and reality products this month, you'll see massive improvements.
Thank you, Mark. There are still lots of questions there to be answered, but I think we should maybe draw this to a close. It's been a fantastic session, and thank you to our brave presenters, live demonstrators. That was great, and we will endeavour to obviously provide the recording, further information, and maybe answer some of those questions that we didn't get to that were upvoted in the follow-up email. But just thank you for joining us, and please register for the next one. Thank you all.